Okay. All right. So let me go back. So graphical analysis in R. All right, graphical analysis, as the name depicts, graphical analysis. You are plotting graphs and charts, and you're using these to represent your data. So there are lots of things you can do with graphs and charts. Everything cannot be covered today, but the more you practice on your own, the better you become at using graphs in R, because you can do actually a lot of things with graphs in R. You can manipulate graphs in R to whichever way you want it to be, whichever color, and so on and so forth. But then it will take a lot of practice to be able to use all of the functionalities for graphs in R. But we're going to learn in the basics. Okay, so graphs help you to provide insight into your data, of course, and then um, statistical analysis requires you to create graphs to be able to further somebody. Oh, okay, 3 minutes. So helps you to create graphs. Helps you. Okay, in statistical computing, you have to create graphs, right, to be able to provide more insight at your in your data. Maybe not just more insight, but maybe for you to be able to look at your data at a glance, or look at your graph from looking at your graph at a glance, you can easily say how your data is, or what the distribution of your data is like, or what percentage of something, who are the top 10 distributors, probably for sales data, and so on and so forth. So there's a lot of things you can do from you can get. There are a lot of insights you can get from plotting graphs and charts. So that's about graphs and charts. And then today we'll be looking at various types of plots drawn in R. So we have plots with single variables, we have plots with multiple variables, and we have special plots. Today we'll be looking majorly at plots with single and multiple variables. For special plots, we might not be able to do that today because of time, but then we'll go as far as we can before 3 o'clock. Oh, that seems like a long
Sorry,
time.
ma'am.
Okay. Yes.
Daniel said he's in the lobby. Can you admit him, please?
I can't find him. He's not. I would have gotten an alert that he's actually not. So maybe you should try going out and coming back, because I can't find him here. You can see it yourself. He's not. Okay. I'll definitely hear if he's in the lobby. But you can still alert me though. If he says he's still in the lobby, I can just check again. But he's not here, like you can see. So okay. So plots for a single variable. Plots for a single variable are plots that show probably daily sales of a particular product over time and so on. And then we have different functions we use for that. We have histogram plots, plots.ts of y. That's for time series plot. And we have pie. You know what pie diagrams look like. You know what histograms look like. Um, and then we have the plot function for showing the values in the sequence. So these are the functions we use for plotting single variables. Now, these are different types of plots we have: histograms, index plots, time series plots, and pie charts. Time series plots help you to forecast. So you can see the trend of data over time, and based on the trend of data you are seeing over time, you can forecast. Okay. Then index plots are okay. I think it's there now. So now I just came here. Okay. So index plots are like plotting. You're just plotting specific points on, instead of plotting it as bar charts, you're plotting it as dots. So instead of a bar chart to just be one, instead of it to just have one single bar for each representation, you have all the data points encompassed in that bar. We'll do an example of it so you'll be able to understand clearly what I'm saying about index plots. So those are the kind of plots we have. Then histograms. So this is what histograms look like, and histograms help you to display the spread of your data, so you can see how distributed your data is from plotting a histogram, how probably smoothly distributed or whether it's skewed to the right or to the left. By skewed to the right, I mean you have more data points at the right or you have more data points at the left and so on. So that is what histogram helps you with. And then the function for that is HIST into two brackets, which is hist into two brackets. So that's the function for creating histograms. And then you can create your histograms based on beans. So you can classify your data into beans. Say you can say I have a huge set of data. My minimum value in that particular data column is 0. My maximum value is 20. So I can say, okay, I want you to plot one bar for 0 to 2 points. Anything under 0.2, I want you to count it and put it into one bar. Anything under 2 to 4, I want you to count it and put it into one bar, and so on. So that is creating bins for your data so that you don't just have so many data bars. You can actually categorize your data into bins. So that is about creating histograms. Then I'm trying to see if I can just quickly do an example. Okay, most of the things we will do will be in the lab, so let's just move. Then um, for histograms, when you want to normalize your data or create a bandwidth, you can use this. This is more applicable when you are dealing with a huge set of data. You want to um, get a good bandwidth for your data. You can use this, where n is the number of data points. So if you have 1 million data points, it here. So you check the maximum minus the minimum over this. So it gives you a proper bin size. So you can say, okay, I'll be using a bandwidth of 10 for each of my data. So I can be using, so I'll probably be using 1 to 10 as a bar, points between 10 to 20 as another bar, points between 21 to 30, rather 11 to 20, 21 to 30, 21 to 40, and so on for each of my bars. So you can use this when you have a huge set of data and you want to know the most suitable bandwidth to use for your data. So this is the formula you can use to do that. But then that is not very applicable right now because we're not dealing with huge data sets. So maybe. All right. Okay. So index plot. So this is what index plot looks like. So it plots all the points of your data, all the points in your data on your graph. And if you categorize your data into bins, it will plot all the points on each of the bar. Instead of just giving you just straight bar points, it gives you all the points within that bar. So this is what index plots do for you. They plot all the sample data in your bar. Something index plot helps you do is it helps you see if you have any anomalies in your data. So for example, look at this. This is very abnormal. So we have all these data points between say 0 to 4 for the response Y, and then we have all of them encompassed here, and then we have just one here. This is about 22. This is an outlier. So it helps you see outliers in your data and helps you quickly pick them out. So probably somebody entered something wrongly. Say the person wanted to enter 2 and the person entered 22. So it could be something like that. So you could use index plots to quickly determine and to quickly pick out anomalies in your data. That's what index plot does for you. So it plots all your points into a graph and then you can easily detect anomalies. So you use the plot function to do this. We're going to do a sample of it. And time series plot. Now, time series plot, I told you it helps you show trend over time, and then it also helps you forecast. So based on this trend, you can see that it's been going up, down, up, down, up, down. So you can easily say, okay, you probably most likely have another up, down, up, down. So based on this graph, I can easily do some analysis to forecast and determine the next point I will have when I have years greater than 1980. So that's what time series plot helps you do. And then okay, two functions. So these are the two functions used for time series plots: ts.plot and plot.ts. those are two functions used for time series plot. So this is plotting three different variables on the same graph, and we have three different kinds of graph. You can see one is line, one is dash, and one is dot. So we would do an example of that in our lab manual. So that is about time series plot. Then pie chart. So pie chart too, they help you to illustrate proportions. So you have a set of data, and you want to see how um, how much of a particular element in your data, how much it occupies in comparison to the whole data set. So you have a data set, and then you want to see how much each of these elements occupy in the data set. So it takes your data and puts it into proportions based on 100% over 100%. So it takes your data over the total sum that you have, and then converts it into a percentage. So it's the percentage that the pie chart plots for you. I'm sure we all know what pie chart is. I don't need to go into details, but then um, like I said, it helps you take proportions of your data. It turns your numbers into proportions, or your vectors into proportions, and then divides the circle based on the proportions. So that's what the pie chart does. And then this is an example of a pie chart. Yeah. So that's about pie charts. Then we also have the strip chart function. So this is strip chart function, and then it's okay. So that is index. I was mixing index and strip chart. So index helps you plot all your values, whichever way they are, but strip chart plots your values on a particular data, on a particular point. So for index, you have continuous values. So you have continuous values like, and when I say continuous values, I mean maybe height, width, and so on. But for this, you have categorical values. And let me explain what I mean by continuous and categorical. Categorical is, it can be easily counted. So see, we have A, B, C, D, E, F. Categorical, things like say you're looking at um gender, male and female. So male, female. It tells you male 20, female 32. That is categorical. But continuous is height, height of students in the class. Then you have to put your x-axis as 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on. So you have just a number chart going on and on and on. That is a continuous variable. But a categorical variable can be easily counted, such as things like gender, things like what again? What again can I use? Um, things that you can easily count. I don't know. I'm lost. I'm lost with examples now. But then I hope you understand what I mean by
Um,
continuous. Yes. Tell me something.
I said car brand.
I didn't
I
hear
should
that.
go buy.
Did
I'll
somebody
just give
hear?
you an
Can someone repeat what
example.
you said? Yes. Yeah. I know
He
you're giving
said
me an
car
example.
brand. He said car brand. Car brand.
Car
Brand
brands.
make.
Okay. Thank you.
Okay.
So car brands, you can easily say, okay, we're dealing with 10 car brands, and then this is this, and this. But continuous variables are most of the time numerical, and then they keep going on and on. And then you can go as far as 1 million and 1 trillion and so on. So those are continuous variables. So this is a categorical variable, and then you can see that the points are plotted on each of the variables. You can see them. So this helps you plot all your data points, but then plot them on each of the variables. So this is a strip chart function, a strip chart, and then a strip chart function is plotted with I think it's plotted with plot function too. Oh no, it's plotted with the strip chart function, and then I'll show us how to use the strip chart function to plot a strip chart. So that's for the strip chart function, and then okay, this is just knowledge check. Yes. So uh okay, you know what? Let us just go through the slides and then go into practical straight. So let me not go between slide and practical. So let me just complete everything. So there are two types of variables. We have okay, before I move on, any questions? Before I move on, any questions, please? Okay, so I'll take it that there are no questions. So let me move on. Give me a minute, please. Okay, so I'm moving on. Plot with two variables. So we did plot with single variables, and now we're looking at plot with two variables. So plot with two variables, we have the response variable and explanatory variable. Now, the response variable is represented on the y-axis, and the explanatory variable is represented on the x-axis. So, as the name implies, explanatory. So, the x-axis is what explains your data to you, while the y-axis is the one that gives the response. So, it tells you, okay, you have this number of this point, or it gives you frequency, or it tells you it gives you an answer based on x, based on the value of x. So y is a function of x, right? We all know that. We all remember that y is a function of x. So x is the one that explains it, and then an answer is given to you by y. So y is called what the y-axis is what gives you the response variable, while the x-axis is what takes in the explanatory variable. So explanatory variable is represented on the x-axis, and response variable is represented on the y-axis. So those are the two kinds of variables we have. Don't be confused by response variable and explanatory variable. It is the variables on the y-axis that are called the response variable, and the variables on the x-axis are called the explanatory variable. As the name implies, explains your chart, or gives, yeah, explains your chart basically. So the kind of plot produced depends on the nature of the explanatory variable, right? So if your explanatory variable is continuous, like I explained to us, um, you have a chart that shows a continuous, that is continuous, so to say. So you have, if you have years, like years is a continuous variable. You are going to have a chart that is probably like a time series plot or a scatter plot. um a scatter plot is the one that just represents all the values together. But if you had a variable that was that is not continuous, that is categorical, you have height, maybe I said you have height, okay, you have gender, or you have name of cars, or you have name of flowers, or things like that, you'll probably be having things like bar charts. Okay, you'll be having things like bar charts. You'll be having things like box and whisker charts, which I would explain to us. Box and whisker charts are like bar charts, but then they represent quartiles or in your data. They don't just represent frequency like bar chart does. So we'll be seeing examples of that later. So your kind of plot is dependent on the nature of your explanatory variable. So, okay, see, when it's a continuous variable, length, weight, and all, a scatter plot is used. When it's genotype, okay, like genotype, like AAAS, you can count that. Color, you can count colors, gender, and so on. It is you represent it by a box and whisker plot or a bar plot. So, these are the two kinds of variables we have. So to create a scatter plot, you use plot x comma y. X is your first data one, or column one, and y is your column two. So you have your explanatory variable and your response variable. And to plot box and whisker plots, you use your factor and y. So you have different factor levels, and you plot it by y. I will explain that when we move to box and whisker plots. Then for bar plots, you do bar plot of y. So bar plot of y plots the height of your vector of y value. So you have one bar for one factor level. So your factors, you have factors the gender, like gender and like all the other things. You gave an example of car names. So you have factors like car names, and then you're going to have one bar per car, right? So that is what a bar plot shows you. So you're just plotting, you're going to be plotting a bar based on your values, but it will be one bar for each factor level, and then we'll be doing an example of that soon. So same thing with this. Okay, I explained box and whisker plot already. One box plot per factor level too. Same likewise with this. So they work similarly. It's just that bar plot looks like a bar, of course, while a box and whisker plot is a bit different. It shows more details, and we'll be seeing the examples soon. So types of plots available in R: scatter plot, step lines, box plot, and bar plot, which will be practicalizing in a minute. Then so okay, so scatter plot. So this is an example of a scatter plot. So this is an example of a scatter plot. And a scatter plot usually shows the relationship between two numbered sets. So a scatter plot, you are checking two numbered data sets. You are checking two um, numbers or two numbered data sets. So a point is represented by two numbers. So a point has x comma y, like we all know. Let me remind us coordinates. So coordinates, you have coordinate x comma y for a particular point. So for example, this point has coordinate x and y. Say 10 by maybe 20.5. So 10 comma 20.5, that is what represents this point. So that is the coordinate of this point. So for a scatter plot, you have numerical values, and then it helps you show the relationship between two numerical values. So you want to see the relationship between two columns, and both columns are numerical. You can use a scatter plot. So now you can see that there's a good correlation between these two variables, because we have the points encompassed onto a straight line. So there's a strong correlation between these two variables as indicated in this chart. So that is what a scatter plot does. It shows you the relationship between two variables. And then okay, this is the function for this is what you use to plot your scatter plot. Like I told us, you use plot x comma y. And then you can also use plot y. This is not a comma, this should be tilde. Y tilde x can also help you to plot your um plot x your scatter plot. Yes. And then you can also put in arguments like the name of the explanatory variable, which is x, the name of the response variable y. You can also put the syntax for the plot function is like this. Okay, like I said, this is what it looks like. And then this is the figure that shows the scatter plot. So that's basically what a scatter plot is. In the practical session, you would understand all of this jargons I've been saying better. But I hope we are following. Any questions before I move to the next slide?
Lastly, you emphasize the difference between the bar plot and the box and whisker plot.
The difference. I will show you an example of box and whisker. Then you know what a bar chart is, right?
Yeah.
Okay. So there'll be an example of box and whisker, and then from the example of box and whisker, you would see the difference.
Mm.
Yes. It would be better for you to see an example. I will not be able to explain it by mouth. So you will see the example now soon. So any other question? Any question else? Any other question? Okay. So let's move to part two. So I'm not going to be completing these slides. We can't finish everything today. So I'm going to be stopping before we move into multiple variables plotting. So we're going to do that next time. We're going to do for multiple variables next time. Next class. So this is an example of a plot function. Now, this is telling us that we are plotting data one by data two. COL. So I'm going to give us a list of some key things we need to know, so that when we add them to our plot, they could be really useful in helping us edit the colors, the axes, add the labels, increase the size of the labels, and so on and so forth, add legends and so on. So I'm going to be giving us some of those things, but let's just explain what is currently here. Okay, so COL, which is call equals to red, changes the color of your chart to red. Now, this is supposed to be XLAB. So XLAB is the label of your x-axis. So this means that XLAB equals to explanatory variable in two quotations. Is telling you that I want you to label my x-axis as this. So I want my x-axis to be called explanatory variable. Y lab, I want you to call my y-axis response variable. So that's what this plot is going to do. So this plot is going to plot x by y, x1 by y1, change the color of the chart to red, and label my x-axis as explanatory variable and my y-axis as response variable. So that is what this plot is going to do. So um that is that about that. Then let me see the argument PCH. So there's an argument called PCH. So PCH helps you use different symbols to plot your data. So if I put PCH equals to 16, it's going to be um I'm going to have data points that are triangular. So normally when you plot your data, you have round dots, right? But then using PCH, you can do change from one. You have a series of 0 to 25 to 2 to 5 different kinds of plot types that you can do using PCH. And I'm going to demonstrate this. If you ask me now, I won't be able to answer you. I think I'll be able to answer you when we start the practical. So this PCH, remind me, we're going to do um, something on this PCH using PCH as an argument, and then how you can use PCH to change your chart type. So we're going to do this in practical. So let's not dwell too much on explaining it by mouth. Explaining it by mouth might not work. So um, we're going to use that in the practical. So that's about plotting the plot function. So these are the different kinds of um, let me see the word used. Okay, plotting symbols. Thank you. So yes, plotting symbols. So these are the different kinds of plotting symbols you can use in your chart. So normally when you plot your points, it's usually something like this. If everyone can see what I'm pointing at, usually like dot 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 dot, or circle 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 circles. So this is PCH equals 1. So when you do PCH equals 1, you have this for your point, to represent your point. When you do PCH equals 16, you will have this. When you do PCH equals 17, you would have um, triangles representing your data points, and so on and so forth. You have all of these different points, but the most commonly used are these first two lines. These are the most commonly used. And I'm going to show us samples of how to use the PCH arguments in the practical session. Okay. So you can also add text to scatter plot in R. So for your scatter plot, instead of using dot 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 dot, you can also make it text. So instead of using dot, you can make it text. Maybe text from one of the columns in your data set. I'm going to show us a sample of something like this, something that looks like this in our practical. So you can also do that. Then this is an example of a stepped line chart. You can use to create step lines. And then, okay, there's no example here, but I'll show us an example of this. I hope we have enough time to show us everything. And you could also add shapes to a plot. So you could create shapes on a plot you can use the rect function to create a rectangle. You can use the arrows function to create arrows. You could also use the polygon function to create polygons. Not polygon function now, but then you could use there's a way to create polygons in R, and I would show us how to do that. But of course, this is the rect function. You can use it's rect into two brackets. That's what you use to create a rectangle. Arrows into two brackets. Arrows with two brackets, and you input your argument. But for the polygon, there's a way to create this, but this is not the function used. So you can do these three. You can create these three shapes too in R. So plots showing categorical explanatory variable. I'm just looking at time, and then I feel like maybe we should just okay that plot. Okay, so we're going to end there. So plot showing categorical explanatory variable. So a categorical variable good. There's an example here. So I was not so I will not have to talk too much to explain what categorical variables are. So a categorical variable refers to a variable that holds fixed possible values. So they are not continuous. The values are fixed. For example, in human beings, the blood types can either be 0 O O O A B or AB. There is no other type. So for the normal blood type, there are other types, of course, in medicine, but we are not doing medicine. We are doing data. So O, A, B, and AB, that is categorical. So you plot your chart, and it is just representing on your explanatory variable, on your explanatory axis, you only have O, A, B, and AB as your data, as your point. While you, on your y-axis, you can now have whatever. So this is a category, an example of a categorical variable, blood type. Now, an explanatory variable is a variable that explains about the outcome of a study and usually helps in forecasting. So, an explanatory variable is your x-axis, right? And then, um, and then it's represented on the x-axis. That's what I want to say. So your explanatory variable is represented on the x-axis, and it helps you explain the outcome of a study. So on your x-axis, you put in O, A, B, and AB. So this will help you explain your x-axis. So you can say, okay, for O, we have so number of people. For A, blood group A, we have so number of people, and so on. So it explains your data. That is what an explanatory variable does, and it is usually plotted on the x-axis. So categorical variables are factors with two or more levels. So you can have a lot of levels. You can have under blood type O, there could be other types of blood types under O, and so on. So it could have um, two or more levels. Then when the explanatory variable is categorical rather than continuous, you have to choose between a bar plot and a box plot. So when your explanatory variable is categorical, like I told you, you can only use a bar plot or a box plot. So you can't use any other one. You cannot use your scatter plot or your line chart and so on. It's wrong to use a line chart for categorical variables. And then the box and whisker plots convey more information. That was what I was trying to explain, that the box and whisker plots show you quartiles, mean, median, and so on. And it helps you convey more information than a bar plot would ordinarily do. So a bar plot will probably just show you the frequency, and that will be all. So that's about categorical variables. So for the box and whisker plot, this is what it looks like. So this is the um, median. This is the median of your data. So I'm looking at, let me see if there's a better representation of this thing. There was a okay, it was in the textbook, I saw that. Okay, so let me just do this. So this is the median value. So for one, median value is the value represented here, tracing it back to the y axis. Then the value here is the upper percentile, upper quartile rather. So the value here is the lower quartile. This is the minimum value, and this is the maximum value. So in your data, you have quartile 1, 2, 3, and 4. Quartile 1 is quarter 2, 3, 4. Quarter 3 is usually the, am I right? Okay, quarter 3 is usually the median, which is 50%. Quarter 2 is usually 25%. Quarter 3 is 50%, which is the median. So Q3 is 50%, which is the median. Q4 is 75%, while Q5 will be 100%. So you usually have quarter 2, 3, and 4 being represented in your box and whisker chart. So this is quarter 2, 3, and 4. So 25%, value at 25%, value at 50%, and value at 75%. So that is what this box represents. And the Q3 value is your median value. Now, the minimum value is the value here, while the maximum value is the value here. So anything outside the minimum value and the maximum value are usually classified as outliers. So they do not lie within um, the same range of values in that particular data. So they're usually classified as outliers. So that is what a box and whisker chart does for you. So this is totally different from a bar chart. So let's look at what it says here. A box and whisker plot is a graphical means of representing sets of numerical data using quartiles and is based on the minimum and maximum values and upper and lower quartiles. Box plot summarizes the information available. The vertical dashed lines are called the whiskers. So these things are called the whiskers. Box plots not only show the location and spread of data, but also indicate skewness. So it shows skewness. Box plots show skewness. Then box plots are excellent for spotting errors in data. These errors are represented by extreme outliers. So this box plot brings all the data, all the how will I put it now? It brings all the similar data into one space. So anything that doesn't look like the data in this range, it brings it out, and then you have to check this point. So sometimes these points are actually not outliers, but they give you room to be able to check your data and see that, okay, this data is actually correct or good enough, or I can move on or something. But then I can move on with my analysis. So box and whisker plots help you to check the spread of your data. So this is the spread of the data, but then there are some data points that are outside this categorized spread. So these are called the outliers, and then it helps you to see this, and then you can check and say, okay, I can move on with my analysis. This is not an outlier. And then if it is, you would be able to make corrections in your data. So that's what the box and whisker plot does. And then, okay, I've explained this part. So that is about the box and whisker plot. Then for the bar plot, I think we all know what a bar plot does. For example, you want to see, say height of, okay, okay, let me just use the example used here. So these are the explanatory variables. These are different treatments. As you can see, they are categorical. They are not continuous variables. And I want to see, this is mean yield. So mean of all the data sets, all the data points I have in control. I could plot it, then mean of these two, and so on. So these are mean values of each of the explanatory variables. So a bar plot is simple, and then something we use most of the time. So I don't think I need to explain that so much. Okay, so I'll stop here, and then I'll go into practical because of time. Any questions before I move into practical? Any questions? If there are no questions, we'll just move into practical session.
I think there'll be tons of questions. No, we'll go practical.
Okay. All right. Thank you. Thanks for the response. So practical. HD user. Okay. Let me clear here. All right. So let me save as today is 7. All right. Okay. So um, let's move into practical. So I don't know. I'm confused. I don't know if I should just if I should first start with the simple things I know before moving into practical, or I just go straight into practical. Give me a
Please, the
minute.
simple one, so before our head break.
Wait, I need to know who spoke. Who talked? If you're the one that spoke just now, raise up your hand. So you will not raise up your hand.
I can't actually, but I was using my phone, so I was the
Who did
one,
that?
Sunday.
Oh, Sunday. Why your head break? Your head will not break. Oh. It will just be full, and then when it gets full, you go back to your manual, and then you digest the things that you're supposed to digest, and then it becomes calm back. But then the knowledge won't go anywhere. So don't worry, your head cannot break. You'll be fine. So let's start. Okay. So you said the simple ones first. You said I should just do the simple ones before I jump into the manual. So let me actually do that. Mm, okay. All right. So okay. So let's look at data. So I'll just do a lot of things from some small things I jotted down, and then some things that whatever comes to my head to just explain. And then when I'm done explaining that, then I'll go into the manual the practical session. So I want to see the data sets in R. So these are the available data sets in R. So let me use air passengers to show us histogram. So air passengers. So let me just see what air passengers looks like. I think it's just one data. So this is it. It's just one column. So I have just one column in my air passengers data set. So I want to create a histogram with the air passengers data sets, right? So HIST, like I told you, the function for creating histogram, HIST, air passengers, then yes, let me just do this first. Um, so this is it. So it automatically categorizes your data into bins for you. So this is a histogram, and then you see that it just helps you categorize your data into bins. Now let me do something. Range. So let me see the range of values in air passengers. I want to see the range of values. So my values start from 104 and end at 62. So what if I just wanted 5 bars? I don't want so many bars. I just want 5 bars. I could do something. I could say histogram, then air passengers. I want you to use a sequence. So I told you SEQ is for dividing your data, and then you can put um how much how you want it to skip your data. So I know my data starts from 105 and ends at 62, and I want all my data to be encompassed. So let me put my start from 100. Let me put my x-axis value starting from 100, and let me end it at 700, so that all my data is encompassed into this. So this is a good reason for checking your range, so that no data points are outside the range that you are using. So you see all my data points are within 104 and 160. 104 is the minimum value. So let me explain what range means. Minimum value, maximum value in my data set. So this is the minimum value in my data set, and this is the maximum value in my data set. And I want to encompass everything. So that's why I use 100 to 700 to represent my x-axis. Then how is marvelous just coming in? Oh, I think it was in before. So let me skip it by 100. So um I want to have it skipped by 100. So I want to have 100, 200, 300, 400, 500, 600, 700. That's the way I want to have it. And then I want to change the color. It doesn't have any color. So I want to put a color. So I told us COL is for changing the color of your data set. So let me change the color to green. Yeah. And then let me put a title. So when you want to put a title, you use main. So main helps you put a title. MIAN. So just taking note of all of these little arguments I'm adding. So main helps you put a title to your plot. So let me put, I don't like the title that is here. So I can either say main equals to M, meaning that I don't want any title, or I decide to put the title I want. So let me put the title I want. Air passengers. I want air passengers. And then I also want to put a label on the x-axis, or I could decide to exempt the label and make it M. So let me do M so you understand. Let me make Y M2, Y label M2. Oh, M. M. I hope I'm right. Then what again do I want to show? Let me see. There's some other argument I also still want to include. Um, I want to try
Sorry,
to
ma, where would
explain
that
a lot of arguments. Yes.
okay, sorry,
Oh, sorry.
what's that mean for and where would it appear in the histogram?
So main is the title of your histogram.
Okay,
Yes,
okay.
main is the title. So I don't want anything to, I don't want my labels to have anything. I don't want to have any label for my x-axis. So I'm going to put an empty quotation here. And then I don't want to have a label for my y-axis. I'll put an empty quotation here. Then I'm trying to explain a lot of arguments at the same time. A lot of arguments you can use for your plot function. Then I also want to um, okay, so let's do this for now. Let me not put so many arguments. So let's see what this gives us. So start from 100, stop at 700, skip by 100. Or let me do skip by 50 so that you don't get confused by my 100. Then color is green. My title is main, which is air passengers. My X label, I don't want anything for X label, I don't want anything for Y label. So let's see what this gives us. So here, so it has changed my color to green. It skipped by 50. So you can see 100, 150, 200, 250, 300. So I have bars for 100 to 150. I have another bar for 150 to 200, and so on. 250 to 250, another bar. 250 to 300, another bar, and so on. So that is the way I specify my range of data values. I specify the color. I put the title I wanted. I removed my X label. I don't want anything. I also removed my Y label. Now, if I wanted to put something as my X label and say um, number, okay, so let me come down. Let me say air passengers, and then frequency. Oh, okay. So here, so I specified the X label and the Y label. So now, what does a histogram do? All the values between 100 and 150, it counts them. So it comes here, looks for all the values that fall between 100 and 150, and then counts them and puts the frequency here. So that is what it does. That's what this does. So that is about histograms. Any question about this particular histogram? Try and move on. So I'm taking it one step after the other so that you will not eat me raw. So any question before I move on? Because Sunday already said I should take it. I should do the simple ones first now, so I will not blast your head. So any questions? So before I move on to the next thing.
Okay, my head is still in order. It's not yet scattered plot yet.
Okay, okay. So you said it's editing in order. Okay, so I'll take that as no question. So I think that was very, very
Please, I have a
understandable.
question, Papa.
Okay, yes, go ahead. Listen.
Yes. Um, for the data between 100 and 200, what's
You're
the
not loud
frequency
enough.
since
Oh.
it is a...
You're not loud. I can't hear you.
Okay, can you hear me now, ma?
Yes, I can hear you now.
I said for the data between 100 and 200, what is the frequency since the bin is a little bit above the range of frequency we have?
Okay, you're asking what the frequency is.
Yes.
Okay, so you're saying that we should try to extend this, right?
Yeah, I just want to know if it is possible.
If it's possible to extend it. Um, let me see. I know about specifying the x-axis, but for the y-axis, mm, okay. Mm, there should be a way to specify the y-axis. So, for example, now we're able to specify the x-axis for the y. Okay, so
I'm
let's take
checking
note of
the,
that. Let's take
the
note of that. You're checking the what?
I'm checking
Yes?
the help session for histogram plots, and I'm saying y x lim and y lim specifies the range of the values.
Yes, thank you for reminding me. Yes. So xlim, let's do xlim. So let's just put it here. Thank you. So xlim, you can do 0. Thank you. Thank you for reminding me. So 0 to 30.
Since it's y,
Let's
shouldn't
do
we use
y.
y
Yeah, yeah,
y
yeah.
lim
Y
instead?
lim. So y lim 0 to 30. Um, so that's it. Yeah. So that's it for y limit. And if we wanted to specify the x limit, we specified the x limit here already. We could still increase it if you want to 0 to, oh, so it's starting from 100. So if you do 0 to, you have 0 to 100 being empty. So you can make it um 100 to 800, which doesn't make sense. But then just to show for the x-axis, so that's it. So you have this place empty since you don't have any values after 622. So yeah, so that's, thank you very much for reminding me. I almost forgot. It's actually part of the list of the arguments I want to give us, but then too many things in my brain at the same time. So I'll still give us the list of all the arguments you can specify in your plot functions. I have a list of everything, and then I'm going to type everything here. But then let's still move on. So as we move on, we probably use all of the arguments, but then let's for now keep working with whichever I can come up with. And if of course you have anything to say or any suggestions, or you know something like you just did, while I was still trying to think and remember, you can let me know. You can let me know. There's no crime in that. There's totally no crime in that. Okay, so let me do let me show us the normal plot function. So there's a data called plant group. Okay, and then I want to view plant group. So this is plant growth. So we have this by weight. So we have group by weight. Now I want to um, plot plant growth, group by plant growth weight. So here. So see, it gave me a box plot automatically. So um this is what R does for you. It gives you the plot that is appropriate for your data. So if you come to plant growth, you will see that we have this and this. So that means it's showing us that we have just three groups. We have CTRL, TRT1, and TRT2. And it's showing us the spread of our data. Now, this has shown us all the spread of our data, but there's only one data point that is not within this spread. So we can check this data if we want. So that is this is what a box plot, and I've explained what a box plot does, right? Median, first quartile, second quartile, median, second quartile, third quartile, maximum value and minimum value. So that is what your box plot does, and it's showing you that the data sets that are present in the second quartile are a lot compared to the data sets present in the third quartile. That's what it's showing us. So you can see how wide this is, and you can see how narrow this is, right? So that is about a box plot. And if we wanted to make this a bar plot, I hope I'm right by using bar plots here. Bar plot should be just height. Yeah, I knew it would give me an error. So it will just be the height. So that will be um, group width. Wait. So this is what the bar plot will give me. So if I wanted to specify the names, I would have to say labels equal to plant growth group. Oh no. So there's a way to indicate labels for this. I'm not sure I'm getting the right thing. So I want to indicate labels for the bar plot. I would let me check this back. Then to indicate labels for a bar plot, so let me see. A bar plot takes in just one argument. Okay. So let's come back to this. I cannot process it at the moment because okay. CO I don't want to use the names function, but then let me just use the names function. So names of plant growth rates. Because a bar plot takes in only one argument, so we cannot impute another argument into this small letter w. Um, I'm not sure this will work. If this doesn't work, then we just have to so it's still not working. Okay. So let me get back to us on adding names to a bar plot. I don't know, it's somewhere in my head, but I cannot really place it at the moment. But let me get back to us on this one. And I don't know if, or does anybody
Okay.
have an idea? If you have an idea, tell me. It's not somewhere in my head, but I cannot seem to process it at the moment. Okay. So I would get back to us on using bar plots. Maybe before the end of this class. On using bar plots for names. It's somewhere in my head, but I cannot seem to remember it. So a bar plot takes in only one argument, and then I'm trying to find a way to name this using the plant group. And then I would provide it most likely before the end of this class. So let's move on so that we don't waste too much time on that. So, but for this one, we can actually add the. Do you want to say something? If you want to say something, speak.
Yeah, I have a question.
Okay.
Yeah, concerning the bar and vista, yeah, the bar and vista plot that you presented for the plant group. I don't still understand the concept of that outlier. You mentioned that the two lines or the start and end point indicate the first or the beginning of your data and the end of your data. So why you just keep outlier? That's my
Come again,
question.
please.
You said the bar and vista plot shows the bar, then the vista shows the stretch of your data. So the beginning of the vista is like the beginning of your data, then the end of the vista is the end of your data. So why is there still an outlier if your data is
Why is there
plotted
an
in your
outlier
data?
in the box plot?
Yeah, why is that outlier? That's asking.
Okay. Let's go back to the box plot. Where is the box?
Okay. Just in case, I think I found the name for bar plot.
Okay, tell me.
So it's names.arg.
Names.arg of what?
Names.arg is equals to, then you put the group name. I put the argument in the bar plots. I put in the bar plots names.arg is equals to plant
Okay,
postcode.
here.
That- Yes.
Okay. Oh, that's nice. Thanks very much. But this is not what I was even. This is not what I'm trying
No.
to remember. But then
Okay.
this is good. So there's another way to do this, but then this actually shows how it. So yeah.
The other way I
Um.
saw,
Okay. So this
can you
plotted
hear
it. Yeah. Yes. I'm listening.
me? Okay. The other way I saw using the help function, I be the help, yeah, the help function was using title, then open bracket main equals whatever name you want to give it.
Title
Yes, it works.
like this.
Like I'm not seeing, like after are you typing anything? I can't see anything. Okay, no.
Yes, I'm actually typing.
Continuation of the bar plot line. Oh,
Okay.
yes,
So this is bar plot.
comma,
Let me
yes,
let me put it here.
okay,
Plant growth. Yeah.
yes,
Growth.
yes.
And
Then
then
comma,
okay.
then title equal open bracket main,
Main.
main. Yes, then put whatever name you want to give it in quotes.
Oh, this we are talking about labeling the x-axis. This
Okay,
is going to
okay,
give it title. So it's
okay.
what the previous person gave me that has still worked. But then there's another way to do this. But then basically this is a bar plot. Okay, this is how to do bar plot. And then this is creating bars, not in a categorical form. So this is not a good representation for the bar plot that I want to, I would have loved to create for us. But we can still do another one later on. So about what you were asking, um I don't know, Ebube, I think it's Ebube that was asking me, where is the box plot again?
Yes.
Yeah. Mm,
No, you've edited that already. The plot function
okay.
you use.
Yeah. Okay. Plot air passengers, right? I think that's what I did.
For plant
Yes.
growth,
No, no,
Oh
no,
no.
no, plot growth.
plant growth,
Growth,
Was it plants
growth.
growth?
Yes.
yes,
Okay.
ma'am.
Okay. So plants growth.
Plant growth.
No. Um,
So
what did I
growth
plot?
dollar comma wait. Plant
Wait.
growth wait.
Okay, I think I remember what I plotted now. I plotted these two, right? Good. I can't remember what I plotted. Why is it not here? Did I
I
delete
think
it?
group first. Plant growth group came first. Can you hear me?
Okay, you said what?
The plant growth group came
Came
first.
first. Okay.
It was the first argument. Yes.
The second argument should be wait, not group again.
Wait,
To be great,
okay.
ma'am.
Thank you. So wait, okay. All right. So you were saying that why do we have an
Sorry.
outlier?
Can I ask a question? Because
Yeah.
when I did what you did initially and I had a scatter diagram. So are you saying that we have to be very, I don't know, particular about the parameters we put whenever we're plotting on
Yes, X,
R?
Y. Yes, X, Y. That's where you put it. You have to do it as X, Y. Like whatever you want on the x-axis is what comes first, and whatever you want on the y-axis is what should come next.
Oh. Thank you.
Okay. So Ebube, you were saying that why do we have an outlier, right?
Yes.
Okay. So you have a set of data values, and then most of them are encompassed around a minimum and a maximum value. So you are thinking that why is this one not the maximum value instead? Is that what you are thinking?
Yeah. Why is it not the maximum? Why
Okay.
was that
So if
maximum chosen?
so there's something that data looks at. Data looks at the spread of your data. So for example, if the difference between this and this is very significant, between this maximum value here and this one is very significant compared to the differences between all of the other values, it's going to take it as an outlier. So how will I put it now? Okay, let's say you have one, you have this. Let me just type it so that I'm not talking too much. Yeah, like this girl likes talking a lot. But I actually don't like talking a lot. But let me just let me just type. Type, yeah. No. So look at this. I have most of them have a difference. So I have one, two, three, four, all of this, all of this, all of this. Then I have a maximum value of 9. So why is my box plot not going to take 9 as a maximum value? It's close to 5, right? But then looking at the spread of the data, it's a difference of ones, twos that are there. Okay, so between 1 and 1, maybe 1 and 2, we have difference of ones and twos, and then data keeps encompassing together like that. But then we got to 5, and then we're seeing that the next one is 9, and that is the only one, and there is no other one after 9. It has to raise a flag about 9, even if the difference between 5 and 9 is as small as 4. Do you understand what I just said? Are you there?
But I'm comparing. Can you hear me?
Yes, I'm listening to you.
Can you hear me?
Yes, I'm
Yeah,
listening to you.
I don't know. I you compare other for control and
You are not
PRC get
clear at all. Your
control. I
network
don't
is
know.
bad. Very bad. Your network is very
Wow.
bad. I cannot hear
Okay.
you.
Okay. We can
Try to
go on.
speak again.
I think I'll just check.
I,
I
I
said
can
you
hear
can
you
go
now. I
on.
can hear
You
you
can go
now.
on. You can go on. Just continue. The, I get your point. I get what you said. Yeah, you can go.
You understand?
Yes, I understood what you just said.
Okay. But let me just re-emphasize it. So I have a set of data points, and then there's a continuous. Okay, Ebube said I can type. Is it I can type or he can type? Let me just talk. There is like a continuous flow in the data. Okay, there's a continuous flow in the data, and then it has reached a maximum value of 5, and then between 5 and 9, okay, I could have chosen 9 as a maximum value, but between 9 and the previous maximum value, the gap is a little more than the other gaps that were between those former data sets as they were following one another. It would pick 5 as the maximum and count 9 as an outlier, because there is more of a break in between the two values, because they are the two. After 5 we have 9, so it's supposed to be like maybe 5, then maybe next 6 or something, because that is the way the flow of the data has been so far. But because of this significant difference between 5 and 9, it will pick 9 as an outlier. So that's just what a box plot will do. So that's about a box plot. Thank you for this for that labeling. I would still bring the other method I know for the labeling, but let's make use of names.arg first for now. So that is about backlot. Then let me just move. Um, I want to move to something else. Okay. I'm trying to look at your textbook and look at this at the same time. Okay, so let's do scatter plot. I'm going to go into your textbook now, because basically I think I've been able to just put the explanation around, explain everything around basic plotting. So maybe I think I'll just go into textbook. Okay, so let me go to the textbook. So the lab is basically just understanding all of what we've done so far, in all of what we've learned so far. So I'll just do what is here. So they said we should set our working directory to home/Hadoop. So let's don't worry, I'll take it slowly, one step at a time. So just follow me. If you follow me, you would understand. S set working directory to home. Let me set to home slash Hadoop and yeah, there you have it. So let's see if it has been set. Yeah. So I want to get a data set, and the data set is dailyspend.csv. So it's already here. Anyway, okay. So I'm on this particular place. So let me do something. Let me go back because we're learning everything at the same time. So I'm back on my normal working directory. So I want to set my data set. I want to set my working directory to home slash Hadoop. Or I want to see the data set present. So I'm going to data set folder. Data set folder. So I'm on data sets folder. So let me see if I have the data set they're asking me to use. They're asking me to use dailyspend.csv. So dailyspend.csv is here. So this is dailyspend.csv. So this is what we want to use. So I have it present, so I can go on. So I want to read in dailyspend.csv into dailyspend objects. Let me just use record to send since I'm not assigning anything. So read.csv. So I'm on home slash Hadoop. So I have to put the datasets folder since I'm not in the datasets folder. So I have to indicate it here. So dataset slash daily spend. So it's a CSV file. That's why I'm using read.csv. If it were a txt file, which is a text file, we'll be using read.table. But because it's a CSV file, we're going to use CSV. So we want the header to be present. So header equals true. We want the header to be present. So here, and then we can just check the first values of daily spend to see what they look like, what the data looks like. Daily spend. So this is what data looks like: person ID, person name, daily needs spent, and daily earnings. So this is what it looks like. And we can also check on the title using the names function. Daily spent. So it gives you just the column headers. Okay. So I don't know what's trying to come in.
Ma, quick one. I didn't hear what you said. If it's a text file that I want to check, with dot what?
Table. You use read.table,
Oh,
but because it's a CSV file, read.csv. If you see here, you have different kinds of files here. You have some text files here. You use read.table to read the
Sorry,
events.
sorry,
Yes?
ma.
Yes?
My network was a bit crappy like some 5 minutes ago. I just don't know changed our why we changed to Hadoop,
Because
our
that's where our
working
data
directory.
set is. The data set we're asked to
Oh,
use in our lab manual. We've moved to lab manual. We just added lab manual.
okay.
And yes, and they said we should
Please, what page?
what did you say?
Please, what page, ma'am?
165.
Okay, thank you.
Yes. So this is the data set we are using. The data set is present in the data set folder. And we could have just set our working directory to data set, but we don't want to do that. So if you don't want to do that, you're going to have to indicate it here when you are reading your file. So that's about that. Then what are we asked to do? Okay, so we want to get profit. So we have daily earnings and daily spend. So we want to see how much is left after an amount of money is spent. So let's name that profit. So profit will be daily spend, daily spend of daily earnings minus daily spend of daily need spent. So there. And then let's check profits. So this is the profits. Um, so this is the profit. So we want to um so we want to plot a chart, and we want the chart to show the names of these people and the profits they have. So we're going to plot a chart to show the names of people and the profits. So their names are represented by person name. Okay. So we are plotting person name by profit. So person name, oh, we're taking it from daily spend. So let's not forget. Daily spend, person name, person name, then by profit. So X comma Y. We're plotting daily spend by profit. And then so this is what it's going to give us. Let's see what to give us. So it gave us this. It gave us this. But it's giving us this because it's helping us check the spread of the data. So in a way, it's plotting like a box and whisker chart, but then it's not well spread, so it's not indicating it properly. So if you have this kind of issue, you have to indicate that you don't want it to give you X type. So R has a way of imposing the type of type of graph it feels is best to represent your data. But then you can choose to represent your data with another type of graph. Okay. So let me say I want you to give me, I don't want you to give me this. I want you to give me vertical lines. So I could say type equals H. So now that brings me to the meaning of what type does. So type is an argument, and type helps you specify the kind of chart you want. So that's what type does. So doing this, it changes your chart for you. It's supposed to change chart. Okay, let me see. So I want to change it to vertical lines. So we have different kinds of types. We have points, lines, and so on. So this should change to, let me see if it changed something. Okay, there's an issue. Let me clear this chart. Let me clear this chart and stop it again. Okay. So let me specify type.
I'm sorry, ma. When you ran the command on line 15, what did you get, ma'am?
You're supposed to get like the first 6 lines. Mm. What's the problem? What did you get?
I haven't gotten there. I don't know what. I understand we're assigning the profits as a variable for daily spendings value minus the daily need spend. Am I correct, ma'am?
Yes, that's profit. Yes, yeah.
Okay, so how did you get the daily? Why do we use heads in bracket daily spend?
Because I wanted to get just the first 6 lines.
Wanted to get what?
Just the first 6 lines. I just wanted to see what the data looks like.
Okay, please can you go up? Let me see what it looks like. Okay, okay,
Yes, so I just wanted to see what data looks like. That's why I did this.
okay, man. So the profit is saying the daily earnings in daily spend minus the daily need spend in daily spend. Is that what it
Yes,
is?
yes.
Okay, man. Thank you, man.
So this should help you indicate the kind of graph you want. I don't know what is going on with this. I don't know why it's not working. So we have different kinds of charts. We have P to indicate points. We have L to indicate lines and so on. So for this particular chart, it is not indicating it, unfortunately. And I don't know why. And that is what is specified in the manual. Okay, so let me try something. Probably doing this would make things easier. Okay, let me just follow what they did in the manual. Okay, so daily spends, person name. Oh, person name. Okay, so let's see if this would work. And then let's put person names here. Oh, small letter. Okay. So let me clear this. Let me see what this does. So it does the same thing. Sorry. And I'm trying to change this to something else.
Let's see,
It's
ma.
not working.
Will you take a
Okay.
cup of
So
water?
you know what? What do you say?
Yeah, bless you, ma. Will you take a cup of water?
Oh,
Class again.
no worries. Thank you. I'm fine. I'm fine. So there are different types of graphs. I don't know why this is not changing, but then you could change it to any type you want. And then the funny part is indicating or not indicating this type still gives us the same thing. So I think I need to take a cup of water. Give me a minute, please.
Sorry, Daniel, when you
Yeah.
went to the terminal, the
Okay.
system direct you to home/data/dataset before she listed all the files.
Yes, yes, yes. Or you can just specify list the files in that particular directory if you want. Anyhow you want.
Okay. But if the directory is just home/headphone and you press ls, it's not going to show you whether the daily spend that CSV file is there.
No, no, no. That's trying to list all the folders and everything that is in
Okay.
h.r. So I
Okay.
have to now say list this recursively. So you put ls space dash r. So now we'll now list all the folders, open all the folders one by one, open everything to the barest minimum.
Thank you. I appreciate it.
That's like long cut.
Thank you.
Thank God.
Okay, I'm back. So basically I have no idea why this is not working. But then let me try something. But this is exactly what's in the manual. And so this thing can be very funny. So so I'm telling him not to give me anything and he's giving me something. N means nothing. And I'm plotting this and I'm having zero. All right. I would come back on this later. I'll come back to this later. So let's just move on. Let's just move on. So you can specify the kind of plot you want. Um but this is obviously doing something else. Okay. So let's just move on. I will check this properly, but then you're supposed to be able to specify the kind of plot you want for your data. So let's move to scatter plot. Let's move to scatter plot. So let's read a CSV file. Let's read a CSV file. I didn't check this particular one, but I'm sure this scatter plot wouldn't give us any problem. So I didn't check this particular lab exercise. So let's move to scatter plot. And then we're going to be using a data set. It's scatter raw 1.csv. So, or if you have anything about this, you can speak up, or you are free to talk. If you have anything to say as regards this, you are very free to speak. Or maybe it's I feel like maybe it's restricting us because our data is categorical. So I feel that's why it's restricting us to just using bars. So I don't know. Just it's still the same thing. So let's just go to the next thing. Scatter raw 1.csv. So let's check scatter raw 1.csv. So scatter raw 1.csv is here. So we have it here. So we are loading in scatter raw 1.csv. So let me just copy this and use it here again. So let's say raw data 1, and then scatter capital R. Oops. So I've loaded in the raw data, and let's just see what the data looks like. So this is what data looks like. Um, it has this. So AABB. So that's what we have. And then we want to plot raw data AA. Or let me just view raw data. So you see what it's like. Raw data 1. So this is what it looks like. It's just all numbers. Okay. So we want to plot AA by BB on a scatter plot. So plot raw data 1 AA, and then raw data 1 BB. Then let's use color blue. By using color blue, then we are putting a label on the x-axis, and we're okay. They called it explanatory variable, so let's just follow explanatory variable, and then a label on the y-axis. Response variable. And then okay, that is all. So that is all. So that's about scatter plot. And let's run this. So let's run this. So we have this. So this is plotting AA by BB. Okay. So this is plotting AA by BB. Please, give me a minute, please.
Sorry, please. Who can tell me the meaning of type equals to P? I think I'm lost while she was saying that.
Okay. The P is the for points.
I'm back. So I heard your question actually. You said who can tell you the meaning of type equals to proof. Okay. So
I
type
think she
is
said you're
type
trying to change the type of the plot,
yeah, you're
whether
trying
it
to change
should
the type of
show
plot.
points or
Sorry, please.
lines
Sorry, please. I didn't hear the question. Can you come
or
again with the question?
other kind of things. So P should be for points, L was for lines. Mm,
Yeah.
I think I hear
P
me.
will work for points and lines.
Can you hear me?
No, please. Can you repeat the question? Let me hear the question
N
again,
is for
please.
nothing.
Yes, N is for nothing. Then there's also O. O plots both of them. Like it plots lines and circles overlapping one another. Then there's also there's vertical lines which H is used for. H is for vertical lines and there's N for nothing. So I don't know the effect on that particular chart. That's what I said I'll find out. But that is what type is supposed to do. It's supposed to change the kind of point it gives you on your chart. Are you clear?
Yes, ma. I am. Thank you, ma.
Okay, you're welcome. So I'll check that chart. Sorry about that. I don't know. I'll check that chart to know what is wrong. So I'll come back to that. I didn't want to waste so much time on that. So for the person asking what question we're asking and what question she was asking, we're asking about type. So type is supposed to change the type of representation of your data lines. So whether of your data point. So instead of lines, you could use points, or you could use circles and so on and so forth. So that's what she was asking. So this has created a scatter chart for the explanatory variable and the response variable, and you all know that you can add a title to it if you want. So you can say the title is raw data, and then it adds the title for you. What do you say? Okay. Why lab? Oh, okay. So yeah. Then um, so that is for plotting scatter plots. Then we can also add another data. So want to add another data called scatter raw too. But this is a txt file, so we are going to use read.table. We cannot use read.csv. That wouldn't work because it's a txt file. So let me just use this. Paste it here and do what data to read.txt scatter row to txt. Oh, read.table. Yeah, okay. Then let me see what data to. So this is raw data two, AA2 and BB2. That's what we have for raw data two. So we are going to plot it the same way on the same chart. So now you're not going to use the plot function because you want to add it to the chart, right? So you're going to use points function instead of plot function because you want to add it to this chart. So you're going to change this to points because if you use the plot function, it will create a new chart, and the plan is not to create a new chart. The plan is to add it to this chart that is already existing. Um, you don't need to indicate X and Y labels anymore because we already have it indicated. You don't need to indicate the title. You can change the color to red. And then this is BB2, this is AA2. Okay, supposed to add raw data too. Okay, so now it's added the points from scatter plot and the points from raw data 2 to it. So if I wanted to, I hope you understand this. So if I wanted to add lines to both charts, so to add lines to this first chart, I would do AB line, AB line. This is for adding lines to your chart. Then um, LM, raw data, raw data one, AA. Then I hope we all remember this. This is like, oh, sorry, you're going to do it from B. So this is like y is a function of x. That's what this sign means. So I'm adding a line that represents data points going from y to x. That's what this means. So raw data one, um, what is- so this will add a line for AA, BB to AA, right? So this to this is going to add a line for all the points, and then it's going to add a line that goes across the most dense part of the data. So this is this line has shown us the correlation between the response and the explanatory variables. So we can use this line to find other things like the scope of the graph and so on. And then we can also add a line to the second one, which is BB2, raw data 2, and BE2. So it adds a line to the red one. So that is that about that. And then you could also add um you could also add a legend. But is there anything like legend here? Okay, no. So let me just quickly explain that. Give me a second. Any questions so far?
But can the points be used for histogram or
What
other
did you
charts?
say?
Can the points be used to add can it be used to add data sets or to another chart apart from the scatter diagram?
Points. Did you say points?
Yeah.
I didn't get that question. No. Can points be used to add
Line
data?
32. Can you use it for
932.
other charts? Yeah.
Okay, to add charts to other
Other
plots.
types of charts.
Is that what you mean?
Yes. Can you use line 32 for other types of
Okay.
charts?
I- Can we use points? For scatter plot, I know yes, but where would you want to add another data set entirely to a histogram? Um, okay, fine. We can say we want to see the correlation between this first data and this second data, and they are both numerical values, right? Scatter plot. But when you have a histogram that has maybe um, male and female, which other data set do you want to add? Do you understand the point I'm trying to make?
Yeah, yeah, yeah.
Yeah. So it wouldn't really be necessary to do that with histogram, because a histogram just helps you to represent um it represents it from the x-axis. Okay, you draw your histogram from the x-axis, and then adding another data to it is like putting too many things on one plot at the same time. We're not seeing any relation. We're not trying to check any relationship. It's because a scatter plot helps you check relationship. That's why we can put in two different data sets, and want to check the relationship between them. So the points is used for scatter plots. I've never actually used the points for histograms before. But for scatter plots, yes, because you might want to see the relationship between two different data sets or two similar data sets. So that's about scatter plot. So let's add a
Sorry,
legend
sorry,
to
ma'am.
this.
I have a question. Ma'am.
Okay.
Yeah, I've understood everything. I don't have any question with regards to what you've done so far. What the, so the question want to ask now is the AB line that we made. There are two AB lines we made now. One is for raw data one, the other one is for raw data two. From the plot,
Yes.
they both have the same color. I would like us to, is there a way that we could change the colors of the AB lines as well, just like we changed the plot, the dotted line, the dots from red to blue to black, whatever. Can we also put a query or a coding or whatever to make the line to be distinct so we can differentiate which line represents which one to understand the trend, which one is actually flipping. You get me?
No, come again. You want me to do what?
The AB line, we have two AB lines drawn on the plot.
Okay.
Yeah. So
Okay.
what I'm asking is, is there a way for us to change the colors of the AB lines because they're both black? Is there a way if we change one
Oh,
to
you want
red,
to change?
yellow?
Okay, you want the color to be distinct.
Yes, that's what I'm trying to find out. If
Okay,
we could
and
do that.
you had the color function like
Okay, okay,
COL.
okay. I wanted to know if
Yes.
that
So
applies as well.
what did you say?
I also wanted to know if that was going to apply to
Yes, yes.
this.
Let's try it. Let's try it. Color. So color equals. It should work. Color equals red. Let's add red to this one. So yeah, change it to red. And you can also do that for this one. Yeah, I think. Yes. Since it worked for that one, so yeah, you can
Yeah.
do this.
Thank you very much, man.
You're welcome. So you can make it distinct if you want. Then funny enough, good enough, you can add this AB line to any part of your data. You can specify just a particular part of your data and use it to add a line. So you can say maybe, let's say, okay, let's say you want to add this to the mean of this data. Let me just choose one data. So in the AB line can be used for anything. It's not just for adding lines to your plot. So let me say I want to add it to the mean of raw data 2 for AA2. So let me just pick this. Okay, and yeah, raw data 2. We're always exceeding time, and I don't like it. So mean of raw data 2, and it's supposed to work. Okay, let me do it. Let me indicate, let me assign it to a value. Okay, so I have to assign this to a value. So I assign it to value v. So you see, it could put a line across a median too for you. So that is what AB line does. So AB line just helps you indicate lines generally in your chart, and you can change the line type. So we have so that type didn't work, but then there's this other way to change line types. So maybe we could try it for that one and it would work. The first type changes the type of graph. So I'm thinking that that data could not have changed to another kind of graph, and I want to study the data properly. Sorry about that, my dogs are barking. I wanted to change the data properly. I want to check data properly to see that it's because of the kind of data that we could not change the type of graph. So that one is for changing type of graph. But we also have one for changing type of line. So now change this line to a dotted line. I would use LTY. So please take note of all these things I'm saying. LTY. So let me change it to line type 2. So it's going to change to a dotted line. Okay, it didn't change it. Change this to a dotted line. Let me use, okay, line type 2 is the normal one. Let me see different kind of line types I have. There's two. Yes. Let me look it here. It's still not changing. Mm, to change the type of the line. Okay. I wonder why it's not changing. Okay, give me a second. Let me just see. Um, okay. So, so is for that. I don't know why this is not working. Okay, this is very, very strange. Okay, so what I'm going to do is I'm going to clear this and run this. So we have different line types. There's zero. That's why I said that's things I said I was going to give us. Zero is for blank, one is for solid, two is for dashed, and this should work. So I don't know what is wrong. So let me add this line type. Let me add it to this. So let me use AA and raw data one. Exactly. So, oh, okay. Let me tell you what happened. Let me tell you what happened. So we had a straight line here already, and then it was running it on top of the chart, and then it was placing it on top of it, on top of it. So we couldn't see the dotted lines that it was placing. So the line at the back of it was covering the dotted lines that was coming on top. So it's clearer now. So we have different line types, and let me just quickly say them. Zero is for blank, when you don't want any line. Sorry, I'm taking you guys time again, like last week. I apologize. So zero is for blank, then one is for solid, two is for dashed, um, three is for dotted, then someone is trying to come. Okay. Then four is for dot dash. Sorry, four is for dot
Bless
dash.
you.
Thank you. Five is for long dash, and six is for two dash. So I wanted to really bring out all of this so that just in case, just in case you wanted to do this later, you'll be able to use this. So we have all of this. So you can change your line type according to what you want to see in your data. So that's about line types, LTY. So I think I'm already explaining all of these arguments. Then you could also plot um, scatter plot and add the labels to it. So yeah, I think we'll just continue with the rest next week. But let me round up.
Okay.
Let me round up. So
Yeah.
let's use this data.
So,
Yes, question, question.
okay, the LCY actually works. I think the reason why you're not seeing it is because the lines are actually very slim. So if you increase the width of the length using LWD, you actually see the change of that dash and the rest. I did that now and it worked.
Yeah, I already said it worked. Okay, maybe you didn't hear when I said it.
Okay, I guess I didn't hear. Sorry.
Being here. Okay, there's no problem. It's fine. No, it's fine. It's fine. So it's already worked, and I explained that. That time I was trying to do it over and over again, and then I explained that there was a chart behind, so it was plotting the dashed line. I already plotted a straight line, so it was plotting the dashed line on top of the straight line because it was still at the same mean position. Do you understand? So the dotted line was plotted on top of the solid line. So everything was still solid. So there was no way. Sorry, please give me 1 minute. Let me not cough into your ears. Okay, I'm back. So there was no way we could have seen the dashed line. So I cleared the chart and then I plotted the chart again and I now did it and see it's obvious now. It's obvious now. So I was still coming to using LWD, but it's good that you're even ahead of me, but it's fine. It's fine. It's totally fine. You're free to express yourself. So I was still coming to using LWD. LWD is line width. LTY is line type. So LWD helps you widen your lines and helps you see your lines better. So since he has mentioned it, let me just show us. Since he has already mentioned. So if you use sorry, oh my god, I'm sorry. Okay. So if you use LWD equals to 3, you would have a wider dash line. So that is LWD. We have some other arguments too. I think I need to take some water. Sorry. Okay. So yes. So that's about that. Then let me just quickly show us this. Then I think we'll go into curves. So let me show us this. Then let me show us shapes, and then we'll go into box plots and curves next time. So let me quickly show us this. So we're going to use um pragmatic acid, and pragmatic acid is a text data and is also in the data sets folder. So see pragmatic acid here. So pragmatic acid. So let's quickly do that. I will release us soon. Please just bear with me. Copy, then paste. So pragmatic acid. Let me just use PA so I don't have to write a long object name again. Pragmatic acid. Okay. So pragmatic acid. And that thing you should take note of is whatever mistakes we make here, you should take note of them and not make them again. So let me view my table. Okay. So this is it. This is what pragmatic acid looks like. There's the fecal rate, there's the index, and there's the pH. So okay, so there's something called attach, right? A minute, please. I've been going on and off. I'm sorry. Okay, so there's something called attach. Attach. So attach helps you attach your data to your workspace. Now, let me explain the meaning of that. So if I do attach PA, okay, if I do attach PA, I'm trying to say that, um, okay, so if I do attach PA and I run this, I'm trying to say that I want you to put all these object names in my workspace. Now, if let me show you the data, the attach, the PA data. So now this is the PA data, right? This is the PA data. So that means if I use fecal rate, index, and pH, it would refer directly to this data. It wouldn't need me to have to do this. So I have to do this for the other data. I have to do raw data 2, AA2, raw data 2, BB2, and so. So it wouldn't I wouldn't have to do this. All I have to do is just to input fecal rate, index, pH, and it refers to this data for me. I don't know why I think I'm tripping on something. Sorry.
Sorry, ma.
Thank you very much. Thank you. So I've been taking water since it's not working. Okay, so now I can use my object names, that is my column names, without having to do PA, then the dollar sign, then the column name. I just have to put the column name directly, and it just gives me what I need. So that's what the attach does for you. So I'm going to do that now, because if you did this without putting raw data 2 at the back, it will tell you AA2 not recognized, or AA2 not in this workspace or something. But because we've attached PA to our workspace, it is going to also bring out the object name, such that whenever we use the object names, even without using PA, even without referring to the table, like we refer to the table for this one, it will still plot our data. So plot let's plot the index. We have the index column. So let's plot the index column by the pH column. And then let's attach labels to each of the data points. So this is how to attach labels to each of the data points. You do labels, then we want to round the labels to the nearest whole number. So this is the pH. I want to round them to the nearest whole number. So, or we could decide to round them to 2 decimal places. They rounded them to 2 decimal places in your manual. So let's round it to 2 decimal places as put in your manual. So fecal rate. So we're plotting this by this, right? But then we are using fecal rate as the labels. So we'll plot this by this, but the labels will be this. So when this is plotted against this, the label will be 9.13. When this is plotted against this, the label will be 7.43. So our label is the fecal rate. So round fecal, I didn't get the spelling of that thing. Is it F-A-E? F-E-A-C-A-L. Okay. So F-E-A-C-A-L. Round fecal rate by 2 decimal places. Then another argument we would also pass in here is the POS argument. So it tells you the position of your text. Now there are different positions of text, so let me list them out. Different position of your text, different positions of your text. You can have one. One means below. So this is for LT. This is for LTY. So POS, for POS. So one means below, like put my label below, and two means put my label to the left of my data. Three means put my label above my data, and 4 means put my label to the right of my data. I'll release you by 3:30. Please bear with me. To the right of my data. So that is what it means. So we're going to use POS equals to 1. Okay, and then we're going to use offset. So there's the offset is another argument. So there are different arguments. That's what I was telling you, that we have so many arguments. So offset, so when you specify POS, so now that I've specified POS, I've said I want my position, my data position to be below my data. Now offset now controls the distance offset from the text. So I want it below my data, but how do I want it to be? Okay, I want it to be in the middle, or I want it to be at the side, or whichever way. So I'm going to offset it by 0.5. Offsetting it by 0.5 means I'm offsetting it by 50%. I'm saying I want my data directly in the middle of my data point, or my data label. Yeah, I want my data label in the middle of my data point, below in the middle. So this tells me below, then 0.5 tells me in the middle. 0.5 is 50%. So this is a percentage. So I want my data label below my data point. Then I want it offsetted to the 50th percent area of the data. So that is what offset does for you. So that is offset. Then what again is there? CEX equals 0.7. So there are a lot of adjustments you can do to your graphs. There are a lot of editing you can do to your graphs. So we have CEX, and then CEX tells you the size of your label, of your text label. So normally your text label is say 100%, but now I want it to be 70% of the original size. So let me put this here. Let me put this here so that when it's shared with you, POS is position of data, position of data label, and offset, position with respect to the POS option. So you have whatever POS option you have, then it gives you a position in percentage. So like that one is 50% now. And then there's also CEX. CEX gives you the size of your data, your label size, your label size. So now we have 0.7, which tells us 70% of the normal label size that we would normally have. So that is that about all the arguments that was passed in. So let's run this. Oh, so I know what is wrong. So we did not okay. There's something is wrong. Offset is not a graphical parameter. That is not true. Offset is not a graphical parameter, blah 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 blah. Okay, let me just see what is wrong. Plots. Oh, okay. So these things are supposed to be in your text. So we're supposed to plot the graph first. We're supposed to plot the graph first, then add these labels. So all these are label arguments. All these are arguments for labels, right? So this is supposed to be for the text function. So you plot your data first, index ph. So we'll plot our data first, then we would add these labels to the already plotted data. So that is what we're going to do. So these are not plot functions. These are not plot arguments. These are text function arguments. So let's plot our data first. So here is our data. We plotted our data, and I don't have to do all of that. You can add your main, which is your title. You can add your X label, your Y label, and so on when you want to. But then what I want to teach is this. So now I want to add the text. So this is the text. See, it's so many, but then, so that is it. Let me zoom it so you see it properly. So we can see some of them are overlapping, but we can see that it is below 50%, which is in the middle. And then this is the normal, this is the text size. So that's about plotting your data. Plotting and adding labels to your scatter plot. Now, the last thing we'll do for today before we run off, I want us to create um, rectangles and arrows. Oh, and there's something interesting. Oh my God. Time, piece of time. Then you can do something too to your data. You could say, anything I'm saying, just take note of them. X, if you say X AXT equal to N. Now, if you do this, it takes off the x-axis completely. So that is what this XAXT equals to N does. Okay. So if you want to take off the x-axis completely, you use XAXT equals to N. So it takes off the x-axis completely. So let me do this, and let me bring this here. Okay. So that's what this does. So XAXT, Then if you want to take off for y, you can also do the same thing. Y axt equal to n. So it takes off for y. So that's that. And then let me see. Then I want us to do shapes lastly before. So for the next class we'll do other things. So let's quickly before 3:30. Let me quickly show you how to plot shapes. So plot function. Any questions before I move on? Any questions? Questions, please. Before I move on, I want to know I'm not talking to myself. Okay, if you don't have questions, just tell me you understand.
I understand.
Okay, okay, all right. So I'll just move on. It's as if I'm not getting any questions. So I think it's clear. I hope it's clear. So let me quickly create a box that I would plot my shapes into. So I can easily create a box with the plot function. So a box of 0 to 20 for the x-axis, 0 to 20 for the y-axis, and I don't want any x labels. I want my x labels to be empty because I just want a box. I want my y label to be empty because I just want a box. I want my x axt. I don't want anything on my x-axis. I want it to be empty too. I want my y axt to be empty. I don't want anything. Then I don't want any plot too. So type of plot equal to n. I don't want any plot too. I don't want anything. So I'm going to have an empty box. So I just created an empty box. Then I an empty box 0 to 20, x and y axis. It's supposed to give me a plot, right? But then I said I don't want anything. Let me show you that it's actually supposed to give me a plot. So it would have given me a plot, but I don't want anything. It's going to plot 0 to 0, 0 to 0, 0 to 1, and so on and so forth. That's what we just did. But then I don't want anything. So that's why I said type. And let me show you something about the type I was talking about. Type equal to oh, see, it's going to give me dot and straight line, like I told you. If I did type equal to L, it would have given me just lines. So that data set probably had some things I need to check. That's why that was not working for me that time. So yeah, I have my empty box. I want to create a rectangle. So I want you to take note of this before I create this rectangle. So a rectangle function is like this. It gives you I want to get the exact word that I use in the rectangle function. There's the way they use it, x above, x below. I want to get exactly like that. The way it was used in the text. I put it down somewhere. So okay. So it is like this: x left, y bottom, y bottom, um, x right, and y top. More like I would say it's more like saying um, it's more like when you are saying um, x1, y1, x2, y2. It's more like this. It's more like this. So you have x left, y bottom. Now, if you're saying x left, y bottom, then you're saying something like x here, maybe x at this side, right? And y at this side. So it's like x1, y1. And if you're saying x right, y top, you're saying something like x towards this area and y at the top. So it's like y2, x2, y2. So I could call it this, I call it this. So if this is confusing for you, just think of it like this. Okay, so now let's actually do the RECT function. That's the rectangle function. So RECT, let's do 6699. Um, let's do this. And plot. So this is what it did. This is 6, 6. So it took x equals 6 here, and y equals 6 here, and x equals 6 here. It put the point here. Then it took for this edge, so it uses the two edges, it uses a diagonal. It took y equals 9, x equals 9. It put a point here. So instead of constructing a diagonal, let me zoom this. So x equals 6 here, y equals 6. X equals 6 here, y equals 6 here. It's plotted this point. This point at this other edge, y equals 9, x equals 9. It's plotted this point. Now, instead of constructing a diagonal to connect the 2 points, it went this way to construct straight lines around both points. Do we understand?
Yeah, I
No,
think I
ma.
understand.
Yes, 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 yes,
I'll
yes.
come again.
Yeah.
I'll come again. Now look at just follow my arrow. See, if you follow me, you understand me. Because I used to, honestly, I actually really try to take this thing one after the other. Just follow my arrow, okay? If you follow my arrow, you will understand what I just said. So this point is y1, x1. Or let me just show you. What did I put here? I put x1, y1, x2, y2. So that means x1 is 6, y1 is 6, x2 is 9, y2 is 9. Okay? So let me zoom this. Now, x1, y1 is what created this point at this below here. So this is x1, y1 point. Now, x2, y2 point is here. This is x2, y2 point. So this is x2, y2. Now, because of these 2 points, we're supposed to have a diagonal. But instead of a diagonal, it creates triangles around the diagonal to form a rectangle for you. So that is what the rectangle function does. It creates 2 points, x1, y1, 6, 6, x2, y2, 9, 9, and forms a triangle around these 2 points, and forms triangles around these 2 points. That's what the rectangle function does. Is that clear now?
Yes,
Is it clear?
yes, ma.
Okay, thank you. So that's what a rectangle function does. And then you can have other types, so it's not restricted to anything. It could be 1, 3,
I'm sorry, ma. I'm
4,
sorry.
7.
I'm sorry, ma. Can you hear me?
Yes, I'm here. I can hear you.
I don't know about that, but I'm not so comfortable with that explanation. I'm sorry, because it's looking quite complicated. Because you said the first six is x1, the second six you said is y1, right?
Yes,
And um, the first nine is x2, the second nine is
y2.
is y2. Now, mathematically speaking, if I would want to envision this, I would be seeing a square, to be honest. Because if I can actually draw a plot on this board and then I take those 2 points, you're going to end up getting a square, which has a 3 by 3 square, to be honest. So in this particular one that's a rectangle, I was initially thinking that the first six and the second six will be the first and second phases that are facing each other, the two vertical lines, because they are the shorter ones, and then the 9 9 are the two longer ones. But I don't, with the way you're explaining with the 6 6 and 9 9, if I want to draw that on a graph now, I'll definitely see a square based on that particular description that you've given. So I'm still not clear on how you're picking the point.
I picked the points diagonally. So this is what I did. This is 6, 6, and this is 9, 9.
What? Okay, sorry. What? Sorry, I'm not trying to be against what you're saying now. What it
Yeah,
looks, I think it looks more like a case of when you put the rec, it's going to be x1, x2, and y1, y2. I don't really know. I'm trying to create an
What?
abstract.
Okay, how do you plot points on a Cartesian plane? What is the coordinate? What is coordinate? X,
Your,
comma y, right?
yes, x, y, exactly. Yes.
Okay. So if I say x1, y1, what do I mean by x1, y1?
That the coordinate x aligns it to coordinate y.
Why? To create
Yes.
what? A point.
A point. Yes, exactly.
Exactly. So that is the point that is created here. X1, y1 created this point here. You know, you're plotting a graph. You are not drawing just any rectangle. You're actually plotting points.
Yeah.
So that's why it's on a graph. This is a graph. This is a graph of 0 to 20, 0 to 20. So if I say x1, y1, x2, y2, unless you prefer the x left, y bottom thing, which I feel is more confusing. But if you feel that is better for you, then that's fine. But then x1, this x1, right? And this is y1,
Yeah.
and it creates a point here. So
Yeah.
x from here, x is 6, and from here, y is 6. It
Ma,
creates this point for
excuse
us.
me,
Yeah?
ma. Is it possible for you to just show the labels so it will be easier to understand in
Okay,
the
Exactly.
okay, 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 okay.
Maybe the step
Yeah,
sizes
on
of the
this side.
labels are different. That's why.
Okay, so
Oh,
um
okay.
it's created like a sequence.
I get you now.
Um
Sorry,
Labels, let me put the labels.
I was initially looking at it that they were labeled with the same step size, but with the way this the X plane is stretched out, definitely it wouldn't be the same. So I understand you now. It's fine.
yes, maybe the
Okay, so
same.
I should not bother
Yeah,
again.
yeah, it's fine.
Okay, okay, all right. So let me just take it out. Okay, so it actually puts the this is the x axis for me. Okay, so it actually put the x axis, x label for me. Let me plot this again. I want to see if it will actually put the y label. Okay, um, this is what I'll take out. Yeah, so I've gotten what I need. So I took, this is the label, that is the values. So the XAXT thing takes out the values and takes out the values. This only removes the label. Maybe the label, whatever 0 to 20 is here, 0 to 20 here, that's what it does. So let me plot this now. Let me zoom it. So this is it. 6. This is 6. And this is 6. And then this is 9. And this is 9.
Okay,
This is 4.
it's very clear now. It's very very
So
clear.
is it clear now?
It's very clear.
Yeah, okay.
Thank you. I was
So
assuming that
for
they had this label. Thank
okay. So for this one too, um, x1, y1, 1, 3, and then x2, y2, 4, 7. So you just join the points together, and then you have the rectangle. So that's what it does. But we spent too much time already. For let me just do for arrows. Um, for arrows, you can have 1, 1, 3, 8. Um, so for arrows, you can have this. Okay, let me put it in another position because we've used this place too much. Let me use 10, comma, or let me use 12. We're going to stop at arrows for today because of time. 10, comma, 12, 12, comma, 12, comma, 15, comma, 15, or 15, comma, 17. Let me do it this way. So here, this is what the arrow is like. And then what it does is it creates the first 2 points for this first point. So 12, comma 14. So 12 for the x-axis and 14 for the y-axis create this point. Then x2, comma y to 15, comma 17. So 15 creates this point here. and 17 creates the other point here. Then it usually puts the head on the second point, which is x2 comma y2. Is this one clear? Is this one clear?
Yeah, it is, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
It
Yes,
just
ma'am.
joins two points to one another. And then you can change, you can apply this. This is where we'll stop for today. Code equal to 3. So
Sorry, what
you can
about the
apply
first arrow,
this
ma'am?
and then put, yeah, I'm listening.
The first arrow. How did you? I don't know.
It's
There,
always
there.
going, you use the function arrows, so the arrow is going to be on x2 y2 all the time.
No, I mean the first one on that rectangle.
I created something before, then I cancelled it because it was clashing.
Madam, madam, ma'am.
Yes.
Yeah, please, I need you to do something for me. Sorry. Can you maximize this? Your go back to that. Go back to your the R page. Yeah, thank you. The publish. Now I want you to maximize the publish. I think it's maintaining a rectangular plane because of the height of that particular display. So,
Exactly.
so can you just maximize it, please? Just maximize it.
Okay. Is
No,
it
not
better now?
like that. Upwards. No, don't drag it. Okay. Okay.
It's
You
fine
see that
now.
when you drag it, the first box was almost taking the shape of a square. If you try to move this plane down, I wish I could control the screen. If you try to
Right.
move this plane
Wait.
down, you get a square plane. Yeah.
Yes, you're right. I
You guys
understand what
understand
you're
what I'm trying
saying.
to
Wait.
say? So
Yes,
when
I understand what you're
what
trying
you're
to
actually
say.
drawing is a
That's
square. What you're actually drawing, if it yes, you see, if you keep
since
moving,
they
you're going
have
to
the
end
same
up. It's on a rectangular
maybe
plane.
that's
Now you see that one is now a square.
yeah.
The first shape is a square now, a 3 by 3 square.
Okay. Are you okay now? Like, is
Yeah,
this
yeah,
okay?
yes, I'm okay now.
Okay. So I'm not usually particular about whether it looks like a square or rectangle. I know what I need to get. And then that's why I just left it that way. But then you could have told me since that this was what was confusing you. I had no idea that this was what was confusing you. So I think this is better now. No, we're even going already. Time is fast spent. So if you want to add arrows to both sides, you can use code equals 3. So code is an argument that changes that adds arrows to both sides for your um of your arrow. It adds arrow to both sides. Okay. Then you could also change the angle. You can change the angle to 80. So the angle of your arrow, you can change to 80. Normally, the default angle is 30 normally. So you can change it to 80 or 70 or whatever you want to change it to. Now it added a new one. So the best thing to do is to create a new chart so that you would see all of this. So let me just clear all the plots and then do this again. So you see, it's creating it with angle 80. So the arrow normally was like this. It was at angle 30 to this line, but now it's at angle 80 to this line. So you can increase the angles as much as you want, depending on how narrow you want the arrow to be, and you could reduce it, your choice. Then code equals 3 puts um, arrows on both sides, pointing, I don't know what to call it, on both sides of the arrow. So that will be that for today. We would have to continue next week. I think yes, we'll have to continue next week. I still have some other things that I would have loved to explain before we go, but then because of time.
Open your
So
terminal.
yes.
Can you open your
Ma'am,
terminal, please? Okay, after setting the working directory to agree on R, why
Yes.
did you have to come and set it here again?
I wanted to see. the data set I have present so that I would be sure that it's present in my data set folder before reading it into R. If I read it into R and it was not present in my data set folder, it would give me an error. So I wanted to confirm the data set I had present in my data set folder on in Hadoop. This is a
That's
Linux
good.
environment. So to search Hadoop, you
Yeah.
have to go through here. Is that clear?
Yes, it is clear. One last thing, ma, please. I missed why you're talking about AD line, but I saw the illustration. So is it the same thing as line of breastfeed?
AD line.
Yeah.
AD
AB
line
line.
helps you put AB line helps you put lines wherever you ask it to put a line. That's what it does.
Okay,
For scatter plots,
wherever.
for scatter plots
Okay.
for your data, it does line of best fit. It does the line in the middle for scatter plots because with the kind of function we used, we did y as a
Mm,
function of x, so it gave
mm,
us the line of best fit for both variables. So, but then you can use your AB line function to create lines anywhere you want.
okay. Okay. Thank
Yes.
you, ma.
Any
Irma,
other? You're
for
welcome.
for the arrows, are there like number codes? Like when you write code equals one, does he have an effect to the
Change.
arrows?
Okay. Let's see. I want to also see. So, it should code equals 2. Does not put anything. Code equals 4. Does not put anything. So I think okay. I think there will be other codes, okay? And I would like to check the other codes too. But then I've not really searched deep on that, on the other code to use for creating arrows. So yes. So I would check that. And you can also check it too. You can also check for that too. Yep. So is there any other question?
I don't really have a question. I just really want to appreciate you for breaking things down. And everything is just really, really clear, to be honest.
Okay.
Thank you very
Thank you
much.
very Thank you. And thank you for being patient with me. Okay. All
We
right.
appreciate you.
Okay. You're welcome. You're welcome. I'm sorry for taking your time. We spent 4 minutes over the time we shouldn't be. So
Thank
so
you
bad.
for the
You're welcome. You're welcome. So
time.
okay. I think that'll be all. Since there's no other question. Um I'd have loved to still teach us polygon, but time is fast spent. So we'll just do it next week alongside the remaining tasks that we did not um conclude this week. So I think that'll be all. Thank you very much, everyone. I hope you understood. Some people are not saying anything. There are some people that talk a lot in this class. People like Hubert. Hubert is number one, and then followed by who is it? Like is it Ebube or Henry? It's one of them. They are sharing the same position. They are one. Hubert is one. Then Ebube and Henry two two. So there's no position three because of that. Then Adekunle is four. See, she's the one laughing. It's four. Then let me see. Ah, no, 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 no. Where's Daniel? Daniel is now number
Daniel,
three. Daniel has taken over.
I'm here.
He now talks more than Adekunle.
I'm
Okay,
here.
in short, sometimes he even teaches the whole class.
Daniel is
Daniel,
number one, please. Daniel is number one, please.
Daniel.
Uh,
So
well,
is Daniel number
I'm
one?
number.
I wouldn't say Daniel is number
No, we
one.
were
No,
to
he's
shut up.
he's
We
Hubert.
were to
He's
always
Hubert
talk
that is
in